Hi everyone, Mr. Ince here. I'm going to go ahead and go through the odd questions on this 4445 review worksheet that deals with triangle congruence postulates. Now remember, you have 5 different postulates or shortcuts that you can use to prove that two triangles are congruent. You have side, 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 angle, side, where the angle is specifically included between the two sides that are being used. There's also angle, angle, side, angle, side, angle, where once again that side is sandwiched or included between the two angles that are being used. And finally there's HL, which is hypotenuse leg, that deals specifically with right triangles. Alright, let's go ahead and go through a few of these. First one, state if the two triangles are congruent. If they are, state how you know. So if they are, we're going to be referencing one of the 5 postulates that we just discussed. Looking at number 1, I notice that we currently are dealing with right triangles, so I'm already thinking maybe this is going to be HL. The sides that are currently listed, those would be a leg of the right triangles. And I'm looking at, oh, interesting. So this piece right here is shared between both, and that's due to the reflexive property. And now a 90-degree angle is obviously congruent to any other 90-degree angle. So this is actually, I take back my leg comment, this is actually side, angle, side, congruent to side, angle, side. Let's go to number 3. I instantly see a side that's being shared, so I'm going to put 1 dash there, since both sides have that due to the reflexive property. And then this would be side, an included angle, and a side, congruent to the side, an included angle, and a side. So once again, we have SAS for number 3. For number 5, I notice a side that's being shared, and then I can instantly tell that with both triangles, all 3 sides are congruent. So these two would be congruent by side, side, side. Now let's get an example of one that maybe doesn't work. So let's focus on 4. I'm noticing on this first triangle that we currently have SAS. That angle is included between the two sides. But then on this one, it is ASS, which we know that as highly inappropriate, and we would never write or say such a thing. So this one would be no. Not enough information there. Let's go ahead and jump to number 7. Oh, nailed it. Side, side, side. All 3 of one triangle are congruent to all 3 of another. Let's take a look at 9. We have a shared side by the reflexive property. And right now, this would be side, angle, side. But yet this is side, side, and then an angle. Those two things are not the same, so then we would say no. All right, let's jump down to a different style of question, beginning with number 11. State what additional piece of information would be required in order to know that the triangles are congruent for the reason that's given. Okay, we're going to do 11, 13, 15, and 17. Now remember, with this type of question, treat it like a checklist, and you're basically being told you are allowed to create or make up one congruent statement that would then allow us to use the provided postulate. First thing that I do is take a look at what I have. I currently have a pair of sides, scratch. I know that these are a pair of vertical angles, which are therefore congruent, scratch. And that means that the statement that I need to make is about another pair of sides, and it specifically is the pair of sides that makes the angle that we already discussed sandwiched between them. So that means I want it to be side, angle, and then this side. So JI congruent to side, angle, and then this side, EI. Making sure that I made it so that that angle ended up being sandwiched between the two sides that we used. Next one, let's go to 13. We are supposed to use side, side, side. I already noticed that we have one pair of side, so that takes care of 1S. We currently have XZ being congruent to itself by the reflexive property, so that takes care of the second S. And that means that we need to make a congruent statement in regards to the last pair of sides. So that would be side DX being congruent to side YZ. Let's take a look at number 15. Let me try to zoom in just a touch. That's better. Looking at 15, we're supposed to use side, angle, side. I'm noticing that we already have a side and an angle congruent to a side and an angle. So that means that our one congruent statement is going to be in reference to a pair of sides, and it would be the pair that makes it so that the angle is included between the sides. So that means I must take WU, because once again, this would now be spelled SAS. The angle is included between the sides. Again, that's a WU being congruent to XZ. And once again, the reason we chose XZ is because now in order that would be spelled SAS. The angle is included between the sides. Last one of this type. We're required to use SAS. I currently notice that we have one pair of sides. I know that there's also this second side, GF, is congruent to itself, so that takes care of this S. But then that means I need to make a statement about an angle, specifically an angle that is included between the sides. So that means that I must list this angle congruent to that angle, because then it would be side, angle, side, congruent to side, angle, side. So those two angles that are in question, since they both come out of the same point, as in point F, that means that I need to be more specific using 3 letters. So this first one up top would be angle EFG, being congruent to angle QFG. Okay, let's go ahead and flip over. New set of directions here. We're being asked to tell whether ASA or AAS would be used directly to prove the triangle is congruent. If the triangles cannot be proven congruent, just write not possible. Okay, so the main focus seems to be on angle, side, angle. So is that side included between the two angles, or is it not? Again, we're going to stick with the odds. Noticing this first one, just not enough information. We only have a side and an angle congruent to a side and an angle, and that's it. So this one would be no, not enough information. Sliding over to 3, I'm noticing that I can include a vertical angle pair, which are congruent, and now I currently have an angle, and then a side, congruent to an angle, and then a side. So this would be angle, angle, side. Number 5, I've got 2 lines or segments that are crossing, which create the vertical angle pair. But that's only an angle and a side, congruent to an angle and a side, and that's it. We don't have any more information, so there's not enough there. Number 7. Oh, nailed it. Well, this one's interesting based on our directions, because this would be angle, side, angle, congruent to angle, side, angle. Oh wait, no, that is perfect with our directions. Ha! So this would be yes, ASA. And then finally, last one of this type, number 9. I see a vertical angle pair right there. I better use 2 arcs since 1 arc was already used. And now I have angle, angle, side, congruent to angle, angle, side. So this would be yes by AAS. Last couple sections, let's just do number 11 of this type. This is asking what else would we need to know to prove the triangle is congruent for that specific reason. So this is very similar to the bottom half of the front page on numbers 11 through 17, where we're going to treat it like a checklist and then create one more congruent statement that we could then use this postulate. So let's try number 11 on the back. We need to use angle, angle, side, and I'm taking a look at what I have. I currently have an angle and I have a side. Now, this is interesting because I know that this side is congruent to itself by reflexive, but let's just imagine for a moment that that's what I thought I was supposed to do. That would just be ASS, very inappropriate. So we actually aren't going to use that. So I take that one back. We currently have an angle, and we currently have a side that is not in contact with that angle. And so that means I need to name another angle, and it needs to be an angle that goes in order after the one that we have. And by in order, I mean angle, and then the next thing we mark would be an angle, and then the side. So that means that I need to name angle G congruent to angle, and then this angle, and then that side, AAS. So our statement would be that angle G is congruent to angle J is what would be necessary in order to use AAS for this problem. Kind of a tricky one. Let's do just a couple more. We'll tackle 13, 15, and 17. It's asking what additional information would you need to prove each pair of triangles congruent? Oh, specifically by the HL theorem. Now remember, the H in this one is the hypotenuse. That is the side that is always opposite the right angle in a right triangle. And then that L is just referring to a leg, and a leg would be any other of the sides of that right triangle. Just as a reminder, in any right triangle, this would be a leg, and then opposite the 90 degrees, that's your H, your hypotenuse. So let's take a peek at what we have here for number 13. It is a right triangle, and we currently have a leg, which means that if we're going to try to use HL, the leg is already taken care of, and we need to make a statement about the hypotenuse, which would be opposite of the right angle. So that means that my statement would be that VW, side VW, would need to be congruent to side RS. For 15, I like this one. It doesn't mention anything about angles, but if this were a right triangle, then this would be a leg and a hypotenuse. So that means we need to know that angle C and angle F are right angles. And if that were provided, if that were given, then we could conclude HL. Last one, number 17. We are working with right angles and right triangles, so that's taken care of. We currently have a leg in each of them that is congruent. That means that we need, if we're going to be using HL, that takes care of the leg, and we need to make a statement about the hypotenuse, which is opposite the right angle. So that means I would need to know that side LN is congruent to side PR. All right, everyone. Well, I hope you can handle the evens on your own. You can always ask your sub or ask each other. And I look forward to hopefully seeing you guys, if not Thursday, then definitely next week. Make sure you study up for that quiz on